Hello, everybody. My name is Behnam Mobaraki. I'm an assistant professor from the Department of Graphic Engineering and Design at Polytechnic University of Catalonia, UPC Barcelona in Spain. So in this research, I'm going to present a part of our research which focuses on assessing urban heat islands dynamic in Mediterranean climates, the impacts of building materials, morphology, and urban expansion. So as can be seen, this job has been conducted by assistant professors Abdullah Mubaraki and Mujdini Kufam from the Department of Architecture at Cyprus International University, CIU in Northern Cyprus, Engineer Mohammad Bagher Ahmadi from the Design and Construction Company Areska Iranian in Tehran in Iran, and by myself. So the outlines are as follow. In the first step, I'm gonna give a general picture about urban heat island phenomena. In the second step, I'm gonna talk about the methodology of the study. In the third step, I will talk about the theoretical review, and finally, I will give a brief information about the developed sustainable construction material. In this research, we had a number of research questions, which are as follows. The first one is, what is urban heat island phenomena? The second one is that, what are the causes of urban heat island? The following one is that, what are the factors affect urban heat island? And finally, what are the criteria for reducing the urban heat islands? So regarding the first research question, I can simply say that the urban heat islands refer to the increase in the temperature observed in the cities compared to their surrounding suburban or rural areas. So it describes the pattern where both air and surface temperatures are higher in urban environment rather than in nearby regions. Regarding the following, our research question, what are the causes of urban heat island? I can simply mention that as we noticed, the urban materials like concrete and asphalts absorb and retain more heat than natural surfaces, while reduced vegetation limits cooling through natural moisture release from plants. Additional heat is generated by transportation system, buildings, industrial activities, and the dense urban layout which traps heat and restrict airflow. We can also say that the intensity of the urban heat islands is influenced by the factors such as population density, as well as the size and structure of the urban area. It's typically defined as the temperature differences between the city center and its surrounding suburban areas. And the factors that increase urban heat island intensity include vegetation cover, presence of water bodies, population size, wind speed, and the other geographical or topological factors. Regarding the strategies for mitigating urban heat islands effect, in this study, we have placed the main emphasis on some meteorological factors and urban parameters. Regarding the first one, as can be seen in the table, we have focused on the temperature, humidity, wind, and sunlight. And regarding the following parameter that can be seen on the right side of the table, we have studied the location of the city, the size of the city, density of built-up area, urban geometry, thermal properties of the construction material, building construction material, air pollution, land uses, and wind speed. So as can be seen in this table, we had a case study on the Shiraz city, which is a big city located at the center of Iran. In this case study, we have considered different factors and possible effects. Regarding the factors, we have focused on the city size, on the density of built-up area, population size, urban geometry, and for each of these factors, we have considered different possible effects that can influence the range of the change of this phenomena. And at the end of the study, we have tried, or let's say still we are focusing on the development of a sustainable construction material for reducing the urban heat island. So the aim is to elucidate the coupled effect of nanoclade and some let's say industrial fibers, and studied the role of these new mixes on reducing or better to say that enhancing the thermal performance of building construction material. And after preparing the concrete models, we have established a temperature control box model where the concrete models specimens can be placed on the side of this temperature control box. And by placing and installing some sensors on the different parts of the temperature control box, so let's say interior surface and the outside of the box, we can easily extract thermal performance of we can easily extract the transmittance parameter of the developed concrete models that can give us a general picture on how it can reduce the rate of heat loss from indoor to outdoor. So many thanks for your attention. If you have any questions, feel free to send me an email and I will answer your questions.